Welcome to our next session of solid state, and in this session I will explain you the classification of crystalline solid. So let's start without any delay. Now, classification of crystalline solid. Basically, the crystalline solids are classified in under different categories. So one of them is molecular solid. In molecular solid, we further divide into three categories, that is non-polar molecular solid, polar molecular solid, hydrogen bonded molecular solid. So basically, the constituent particle of molecular solid is a molecule. So in non-polar molecular solid, can be made up of either atom, that is argon or helium, or it can be made up of molecules formed by non-polar covalent bonds, for example H2Cl2 I2. In these solids, the atoms or molecules are held together by weak dispersion forces or London forces. These are usually soft and non-conductors of electricity. They have low melting points and are usually in liquid or gaseous state at room temperature and pressure. The next category is polar molecular solid. So the molecules of substances like HCl and SO2, etc., etc., they are formed by polar covalent bonds. Now the bond is polar because one of them is more electronegative as compared to the other. For example, in case of HCl, this will get a delta positive charge on top of it, and Cl will get a delta negative charge. So that's why this behaves as a pole. Therefore, they are held together by relatively strong dipole-dipole interaction. What's a dipole? A positive charge and a negative charge kept in close proximity. So these solids are soft and are non-conductors of electricity. Their melting points are higher than those of non-polar covalent solid, and yet most of them are in gaseous or liquid state under room temperature and pressure. Another example is NH3. The third type of molecular solid is hydrogen bonded molecular solid. So in this one, we have a hydrogen which can be bonded to either fluorine, oxygen or nitrogen atom. The reason is, since fluorine, oxygen and nitrogen are highly electronegative atoms, that's why they are able to pull away the electrons from hydrogen. So strong hydrogen bonding binds the molecule, for example ice. Okay, and they are non-conductors of electricity. Generally they are volatile liquids or soft solid. So this was about molecular solid. Let's look into ionic solid. So as the name suggests, that ionic solid, so they should be made up of ions. We know that there are two types of ion. One is cation, the other is anion. Cation is positively charged, whereas anion is negatively charged, and because of this they are bonded together by strong Coulombic forces or electrostatic forces. In the properties, we see that these solids are hard, brittle in nature, and they have high melting and boiling point. Since the ions are not free to move about in solid state, they are electrical insulator in solid state. Okay, but when they are present in molten state or in dissolved state, or that is the aqueous state, aqueous state meaning you are dissolving them in water, so the ions are free to move, and that's why they can conduct electricity. Let us look at the next one, that is metallic solid. So they are actually held together by sea of free electron. Since the electrons are mobile, that's why they are responsible for high electrical and thermal conductivity. Now these electrons flow from the network of positive ions. Similarly, when heat is supplied to one portion of a metal, the thermal energy is uniformly spread throughout by these free electrons. The important characteristic of metallic solid is their luster and the color in certain cases. Metals are highly malleable and ductile. Next, covalent or network solid. A wide variety of crystalline solid of non-metal result from formation of covalent bond between adjacent atom throughout the crystal, and this give rise to a giant molecule. Just to tell you, show you an example, is this example is of diamond. So where we see a carbon, and this carbon, since it is tetravalent, it is bonded to 4 other carbon atoms. So 1 carbon up, 2, 3 and 4 carbons are bonded to this central carbon atom. So this is a typical structure of diamond, which is a network or covalent solid. This is a structure of graphite where I see that this carbon is bonded to other three carbon atoms, and this is a layered structure, and this is also a layered structure. In between there are electrons which are flowing. That's why graphite is actually able to conduct heat and electricity. So covalent bonds are strong and directional in nature, therefore the atoms are held very strongly at their position. Such solids are very hard and brittle. In fact, diamond is extremely hard, so it is used for a lot of purpose, but it's one of the hardest substance known to us. They have extremely high melting point and may even decompose before melting. So they are insulators and do not conduct electricity. So typically they are insulators, but graphite is a special case which conduct electricity. Remember this part. So basically here in case of graphite is soft and conductors of electricity. Its exceptional property, that is conduction of electricity, is due to its typical structure. So the carbon atoms are arranged in different layers. So you saw already that it is arranged in layer 1, you can see layer 2, and this is your layer 3. So these layers are there, and each atom is covalently bonded to three of its neighboring atom in the same layer, and the fourth electron of each atom is present between the different layer and is free to move about. Like for example, this carbon is having 1 2 3 bonds. The fourth electron is down here somewhere or up here somewhere, which is free to move about. So these free electrons make graphite a good conductor of electricity. Different layers can slide over each other. This makes graphite a soft solid and a good solid lubricant. So this was the structure of graphite and this was the structure of diamond. Let's continue. So this table summarizes everything, okay, with the type of solid. These are the type of solid that we have gone through. The constituent particle, for example, that is molecular solid, the molecules are the constituent particle. In ionic solid, ions are constituent particle. In metallic solid, positive ions in the sea of delocalized electron is the constituent particle. And covalent or network solid, atoms are the constituent particles. The attractive forces which are holding them, some of the examples: their physical nature, conductivity property, and melting point. Well, thank you all. Thank you all for this amazing session. See you all in the next session. Thank you.